Okay, so this class, we're going to talk about chapter 3 in the book. Hopefully some of you have had a chance to read it. If not, go back and read it after class. But we're talking about literals, variables, and constants. And as we're going through this, it might occur to you that, yeah, we've already talked about some of this kind of stuff. We've done some programming assignments where you were expected to know this, but like I've discussed before, it's kind of a chicken and egg thing. I can show you and confuse you and then explain it later, or I can explain it and you won't understand the relevance, and then I can assign something and you won't remember and I'll have to re-explain it. So there's no right way to do it. So this is the way I chose to do it. So here we go, talking about literals, variables, and constants. So after we get done with this, we'll be moving on to chapters 4 and 5 in the book. So, there's programming assignments, quizzes. Have fun with those, and we'll probably just continue the same pattern we've been as we continue forward. We're going the same order, same kind of content that's in the book, but my expectation is not that I'm going to read everything in the book. You can get that, and I add nothing if I just go over the same material in the book, just with different words. So I'm going to chunk it up and do parts of it as we go. But the general pattern here is I talk about it a little bit. I show you something, about how I would do a similar project. Then you do it, you turn in your stuff, and then I try to keep up with you and keep things graded before we run out of time at the end of the semester, and then I enter your final grades. So that's what we're doing here. Okay, what is a literal? What is a variable? What is a constant? We're going to go over that kind of stuff. It's basic foundational type of stuff that you have to understand about any programming language that you're going to try to learn. So here we're going to do it with Python, but if you try to do a C# class or a Java class, C++ class, you're going to have to understand what are the constants, how do I create constants, how do I create literals and use them, how do I create variables, what are all the data types. And so think of this as an example and focus on the patterns that we're establishing here. And I'm not going to try to get into the weeds on the nitty-gritty of Python specifically. Feel free to do that on your own if you see some interesting topic, but mine is going to be focused on more of the things that are common to all the programming languages. So the Python data types we've been talking about already. We've been using some of those, the character data types, the number character types, floating point characters, which are the decimals, Boolean. Anybody remember what Boolean is? If you read the book already? True or false. Yeah. So some guy named Boole came up with it. Seems like a pretty easy way to get your PhD, right? Inventing true and false, and making it a thing. But it's more than that. He did more of the, a lot of the foundational work, formalizing like the truth tables we talked about last time, and, or, exclusive, or, not, all of those basic things, putting them in a collection, putting it down on paper of how they interact with each other. And it has a lot of application, especially when we try to create computers based on silicon, where we have the ability to set bits to 0 and 1, which is an on or off switch inside the computer. And in the early computers, that was a literal wire that was either plugged in, making a connection, or it wasn't. So it has a lot of application in foundational parts of computers and computer science. Type inference is a thing when we, sometimes we have to cast our things. You know how when we wrap our input statements with an int parentheses, and we put our input statement inside there, and that's when we expect them to enter a couple of digits and we convert that into an integer data type. So that's because the type inference is that the input returns a string, and we don't want it to be a string, we want it to be an int, so we have to cast it manually to something else. So, but in general, it's going to infer that the result of an input statement is a string. That's it doing type inference. If you did, and we'll get into this, this is just supposed to be a list of what we're going to cover tonight, but so I'm getting too deep into it too early. We'll go over that. Variables and constants, like I said, mutable and immutable. Has anybody heard that term before? Okay. You can shock and amaze your friends with how smart you sound when you start using terms like mutable and immutable. They mean something very simple, as we'll see. We'll talk a little bit about memory, begin to talk about memory, and how to do the stuff in Python, and then more stuff about input and output as we go. You know, we've just basically touched on the very basics of the input and output statements that we've got available and how to format our messages. It's a very deep thing with lots of options and stuff, and we'll see more about that as we continue. Okay, literal. You know, as the word means literally something, means exactly what I'm saying is what I mean, right? Literally. I'm not being figurative, I'm being literal. And that's the context that they're using the word literal in the language. So if I type, well, the string containing the word literally is a literal. Also, not literally is also a literal in Python. Okay, they're both string literals. And you know, these other examples, the number 17, the 3.14, please enter a password. All of those are examples of literals in our program. It means what you see there, what I'm typing in, I literally want you to use that as a value. Yeah, so you'll hear them called constant literals, constants, and here's where we get the word immutable. And all the word immutable means is I can't mutate it, I can't change it. That's where that comes from. So once I type in the number 17, I can't tell the computer that, oh, from here on, I want the number 17 to mean the number 18. No, it's literally going to be 17 when I type that in there. If I type in the string with the word literally in it, I can't change that. There's nothing in Python where I'm going to be able to change that word inside in the internals to some other word. You might see things that lead you to believe that you can. Like if I said X equals literally, and then I say in the very next statement say X equals not literally, you might think that I just changed that value. Well, no, I didn't. I have three things now. I have the variable X, I have the literal containing literally, and I have the literal containing not literally. So the first statement assigned literally to X. The second statement assigned the word not literally to X. Okay, so that's how all this stuff works. And I explained this in one of the last two classes. I don't remember which one, or maybe I did it in both. But when you see that equal sign, you have to remember that it means something different than in math. In math, when you see the equal sign, you're expecting it to be an equation. Okay, an equation means I'm going to present two sides of an equal sign, and whatever you represent on either side of the equal sign are supposed to be equal, right? And then you can start changing one side or changing the other. You know, you've got all those rules like I can multiply both sides of the equation by 2, and it should still be true that both sides are equal. You've got a whole bunch of rules like that in math, because that's the way the equal sign works in math. In programming languages, it doesn't mean that. It means I'm creating an assignment statement. On the right side of the equal sign, I'm going to have an expression. And on the left side of the equal sign, I'm going to have a variable. And that tells Python, evaluate what's on the expression on the right side of the equal sign. If it says 7 plus 8, it's going to say, okay, evaluate that. 7 plus 8 is 15. I've evaluated it. Now I know what's on the right side of the equal sign. 7 plus 8 is 15. what do I do with it? Well, the equal sign tells me put that result into the variable that's on the left side of the equal sign. Okay, that's has nothing to do with math, right? That's explicitly what Python does when it sees an equal sign. It assumes it's an assignment statement. Okay. Okay, so the thing on the right is going to be an expression made up of literals, variables, function calls, all kinds of stuff, and it's going to get evaluated and put into the variable that's on the left. Okay, so it's made up of these things called literals, and those literals are immutable. The variables aren't immutable. We can change what's in a variable, but we can't change what's in a literal or a constant literal or a constant. Okay, and here's my slide for the stuff I was just talking about with literal or with assignments. So here's an example. I've got two string literals, okay? What does that evaluate to when I evaluate that expression? Mark. Mark, the word mark. So I evaluate that and I take the word mark that results and I store it in this variable. So the next line of code, if I say print first name, I get mark. Here's another one. 17 plus 4 times x plus sine of theta. Okay, a lot going on there. We haven't touched on any of that stuff yet, but it looks similar to, but slightly different than what we see in math, right? You know, in math, it would look more like that. But here, this is how you would see it in Python. So theta is going to be a variable name. Sine is a built-in function. It takes whatever that is, passes it to the sine function, and returns, you know, the geometric sign of that value. 4 times x, you know, we know the asterisk means multiply, right? And in math, we just put the two terms next to each other, and that means multiply, right? Or sometimes you'll see the dot in math. Anybody seen that in math functions? Okay, so that's math, but this is programming. So it's going to evaluate all of this if it can, and it's going to store the result into this variable. It's an assignment. Okay. Yeah. Okay, here's a bunch more examples of literals. It's kind of interesting when you start programming, you can use this prefix 0x. And I've programmed for a long time seeing the 0x one. I didn't even realize there was other stuff. There's 0b, which means binary, which means what follows can only be zeros and ones because that's all that binary allows. Anybody ever seen this notation before? No, we don't see that really in math. But what this means is take this number and the +1 says move the decimal point 1 to the right. So really that expression means 75.1. Well, why didn't I just type 75.1? Well, I could, right? But that's another way to write it. It means something. It looks ugly, but if you know how that E+1 syntax works, it means something. Same with this. What would this mean? It's got a -6. It's like, yeah, move the decimal 6 places to the left. So it's going to be like a decimal point, 5 zeros, and a 1. 0, 1. Yeah, so it's a very small number, but we could type things that way too. These are, I mean, this is, if you're creating a floating point variable and trying to assign a decimal number into it, this is one way that you can do the assignment. Okay, similar characters. So when you use the single quotes, it's assuming, you know, when you're dealing with character data, it's assumed that you're probably only going to be referencing one character. So I've got a B, you can have special characters inside there. This is meant to be just a space character, so that's a character. The space character is a character. What's this one? Anybody seen that before?
Oh.
What is it?
Oh.
Yeah, that's a tab character. So there's a half a dozen or so of these things where you can say backslash and a special character like \R is a carriage return. So anybody know what a carriage return is? So I'm old, so I remember typewriters. So back when you had manual typewriters, you would type a line of text. At the end, you'd grab the carriage and you push it all the way back over so you could start typing on the next line. It had this little lever, and when you pulled on the lever, it would turn it up a little bit and you push it all the way over and start typing on the next line. Yeah.
You can use \n.
\n. So carriage return is like the lever, because well, actually \n is the new line. So that's like the lever rolling the thing up one line. And pushing the carriage all the way over to the side is like the carriage return. So it's like a carriage return line feed would be a \R\n. So you see that a lot when people are creating strings, they'll put \R\n because it's a carriage return line feed. Yeah, all this stuff that old people know. Respect us. Okay. So these are strings. You can see there, I put a carriage return in the middle of that. So if you were to say print this, you would see two lines of text. The carriage would be on the first line and return would be on the second line. Which you guys can use that. You know, if you're doing input statements and you want two lines of prompts, you can put a carriage return in there and it'll display that way on the screen. Similarly, when you're doing your output, you can use those to put in there and your print statements will do things on multiple lines. And then, of course, true and false. So in Python, it's a capital T and a capital F for true and false. Different languages like C++, it's all lowercase. Go figure. And then this bears pointing out because this will confuse you. Especially, you know, when you're heavily caffeinated at 3 a.m., you'll wonder what the heck's going on. But in many languages, you can use double quotes on the outside and single quotes inside, and it'll literally display the single quotes. Or you can do it the other way around. You can use single quotes on the outside and double quotes on the inside, and it will literally put the double quotes in there. Okay. So if I say double quote H, is that a character? Or is single quote H a character? I don't know. But they're different and they can mean the same thing. So you know, just be aware that how you use those things can cause interesting outputs. So this is a good question though. If I put 9 in double quotes, is that the same as typing the literal 9?
No.
All right, so the reason for that is something we mentioned on the overview for tonight is type inference, right? If I type this, then Python is going to assume or infer that I meant a string or a character 9. And if I do this, it's going to assume that I meant an integer. Why doesn't it assume that I meant a floating point? Because there's no decimal point there. If I type 9.2, it would assume that I wanted to consider that a floating point number. It's not that hard once you see it, once you realize what's happening, but it bears pointing out if you don't. So same with this. Is false in quotes different than false without quotes?
Yes.
Yes, very much the same. I don't remember if I say this later, but there's an interesting feature of strings when we get to the unit about if statements. If I say if double quote false, then it's going to think that's true. So the only way that a string can be considered false is if it's empty. So if I just type double quote, if you put that inside an if statement, it will think that's false. But any string that contains anything other than nothing is going to be evaluated to true. If you try to cast that as a Boolean expression, it's going to say that's true. It's just a weird thing about computer languages. The only false string is the empty string. Okay, file that away, because one of these days, at 3 in the morning, you're going to remember, why is my program not working? Oh, yeah. Yeah, I bet that's because it's a string that contains false, not false. Okay. The next is variables. If you just remember this first thing, that's variables, right? In memory, we have spots cut out to store these variables, okay? But we need to refer to them by name. You know, you have an apartment or a house, but you have to have an address for the house, okay? So a variable is nothing more. If I type X in my Python code, that's nothing more than a name that refers to a place in memory that the Python compiler has set aside as a bucket to hold whatever I'm going to store in that variable. So it's a name for a spot in memory that holds a value. So if you ever see that on a test or anything like that, that's what a variable is, the definition. It has properties. One of them is a size. You know, it's really important when you're learning different computer languages that you remember that different kinds of data have different ways of coming up with the size. You know, if I type the number 17, we know that's an integer, right? But how big of an integer? Is it 1 byte? Is it 2 bytes? Is it 4 bytes? I believe Python considers them 4 bytes by default. But you kind of have to know if you're doing something where it matters. In most of our programs, we're doing things with small values, right? Enter the number of miles that we traveled on this trip. You know, even the decimals. Enter the price per gallon, right? So we don't necessarily, we're not going to be pushing the limits of what these variables can hold. But if you're writing a program where that matters, then you need to look up the size of these data types, which we'll get to that next chapter, and what the min and the max value is. Because, you know, if you're at the min, or if you're at the max -1, and you multiply it by 2, something interesting is going to happen. It's probably not going to store the value you thought it was going to. So you just have to be aware of that. But for now, just realize that these things have a size, a way of calculating the size based on what you infer the type is. And they have a, you know, I'm calling it a shape here, but it's, you can generally determine deterministically what the data type is using the rules of inference for that computer language. And it will vary by language. Yeah, so remember we learned the other word, immutable. Literals are immutable. Variables are mutable. You can store something in it, and then you can store something else there. It overwrites what was there before, changes values, and now it has a new value. And like I said, you can evaluate it. These are just like terminology things that you need to learn. If you're going to be a programmer, you have to speak the lingo and, you know, things like expressions, evaluating expressions, literals, constants, variables. They're just the terminology you have to learn. Okay, this is an interesting statement here. So if I say x equals 17, it says the type is immutable. I just said we can put a different value in it. So what that means is I can say x equals 17, but then in the next line of I say x equals mark. That's a string. That's probably not going to work, right? Because I'm trying to change the type of a variable. Well, that will work in Python because Python is not a language where you have to pre-declare your variables. Remember we talked about that when we were going through logarithm, when you just put a bunch of boxes, you know, ovals, parallelograms and stuff, and you try to run the program and it says, whoa, what are you talking about with this X thing? What is that? Oh, well, in Flowgorithm, it makes you go to the top and declare all of your variables ahead of time. And you have to tell it, I'm going to declare something called X. And by the way, assume it's an integer, right? You have to tell it the name and the type when you declare it before you can use that variable X in your flowchart. But Python is not like that. You don't have to do that. Other languages you do. And there's this huge debate that rages on for years about whether one is better than the other. So right now, Python has a lot of popularity. It doesn't require you to pre-declare all your variables. So you might think that that camp is winning at the moment. I don't know. But it can lead to a lot of problems like my previous example. If I say x equals 17, and then the next statement, I meant to say y equals mark, a string, but I accidentally typed x again, x equals mark, and then I say something like z equals x plus 5, then I'm going to get an error because I can't add 5 to mark. And I just overwrote what was in x from an int, which was what it was supposed to be, to a string. And so now I can't add and subtract and multiply, divide between a string and an integer. So I'm going to get an error. Well, program language that is strictly typed, let's say C++, where I have to declare my variables up front, I would have to tell it what type those variables are. And it would have failed on the part where I said x equals mark, because I can't put mark into a variable that I declared as an integer. It wouldn't let me. I violated the rules. But those rules aren't there in Python, so it would let me do it. So is one better than the other? I don't know. C++ would keep me from doing it. Python lets me do it if there's a situation where I need to. Maybe I'm done with X and I want to reuse that name as something else. So it's a debate. Your mileage may vary, but you need to be aware of it so you can manipulate the languages appropriately. Any questions about that? Have I sufficiently confused everybody that now you're going to have to go rewatch the lecture later? Okay, mission accomplished then. Here's a cool way that you can play around on your own computer and learn more about what these things are. So if you just, I got them to fix this, by the way, on your computers. If you open up a command prompt, you know, hit the start button and type CMD, then you can open up one of these windows. Then you just run Python, and you'll be in the Python programming environment. There's a built-in function called type, where I can pass it something like a literal, and it will tell me what type it is. I can also pass a variable name, and it will tell me what type that is at the moment. So if I use the word type, I put a literal 5 in the parentheses and hit enter. It says it's an int. Pretty cool. That's what I would expect it to be. If I put the word hello in double quotes in here, it says that's a string. Class single quote question mark, you know, so it's a special character. It's a string, right? So that answers our question before about if I put a single character inside single quotes or double quotes, is it different? No, they're both strings. In Python, the book will talk about character data type. Other languages have a specific data type called character, but in Python, everything's a string. It just happens to be a string of length 1, but it's a string. So same thing with this. A double quotes question mark is also just a string. 1.2, that's a float. Here's that weird syntax. So it's 4.09, but move the decimal places 6 places to the right. So it's a big number that starts with 4. Since it has a decimal point, it's just a float.
So a float would be like anything with like integer or like number and letter.
Float will, so type inference will assume that anything that has a decimal point in it is a float. Even if you say 4.00000, it's going to say, well, yeah, but you put a decimal point there, so I'm going to make that a float.
Because that's the point, right?
Yeah. Yeah.
What if it was 4x plus 7 or 6?
Well, those would not be valid. We don't have a syntax in Python for typing it that way, like a math. If you said 4 asterisk x, a variable, plus 6, it would evaluate that expression and tell you what the type of result was. So it's probably going to be an int there, unless
so
x was a float.
letter as an integer, like a regular integer.
Yeah, an integer like a regular integer. Unless x was a float. If x was of type float, that variable, then it would convert the expression to a floating point expression because it wouldn't want to lose that decimal.
Yeah.
Okay, here's a weird one. I did the 2 square braces next to each other. So what is the type of that? That's a type list. We haven't talked about that yet. We'll get to that later in the class. And this, the curly braces next to each other, that's type dictionary, which we haven't talked about that either. So this is a built-in list data type. This is an object of type dictionary. So we'll talk about those later. Those are collections. Yeah.
Do we use the curly brackets the same as we use them in HTML in Python?
No. Completely different.
Okay.
And then here's my good old false. So that's class bool. Okay. So, but like I said, play around with those things. And if you're programming along and you want to know what the type of something is, just print the type of your variable name. And when you run your program and it gets to that point, you'll get a string like this printed on the screen. You can debug your program that way. If you think that's what the problem is. If you think your code is misinterpreting what type of something should be. Pretty cool stuff, huh?
It's kind of confusing.
Yes, it can be confusing, which is the reason why we kind of spent a few minutes on it. Okay, variable naming is a thing. We've got some subtleties around that bear pointing out. Like, if you're on a boat, there's certain knots you use for different things, and there's certain knots that you definitely don't use for certain things. If you're gonna throw a line overboard to somebody that's in the water drowning, you don't throw them a rope with a slip knot in it, because then they say, okay, I've got it around my neck, pull me in, right? That's the wrong knot to use in that situation. And similar, variable naming, there's a way to do it and there's a way not to do it. So the first thing to remember is if you've already used that variable name, you can't use the variable name again, right? You're referring to the same variable name. So don't think you can use the same variable name twice for different things. No, one for one. You can't use a built-in function name. So I can't have a variable named sine or cosine, right? COS. because those are built-in function names. I can't have a variable named str or int, right? Those are already reserved, so you can't use those for variables. The rule in Python is it has to start with a letter or an underscore. So I can't have a variable named 6abc because it doesn't start with an underscore or a letter. It's just the rule. Okay. There's conventions for it. You've probably seen my examples use a case like this. So it's called camel case because it has humps. The capital letters are humps.
I usually use that sometimes.
Yeah, this is my favorite too, for Java, for Python, for C#. That's what I use. Some people are very dedicated to this style where they put the little underscores between the words. Typically, all the letters will be lowercase when people do this. This one is special. So in Python, I would think that the programmer is yelling when they do this. Just, don't do that. But like in C++, the convention is you use all caps when you're talking about something like pi, or some constant that you're declaring. That way, when you look at it in your code, you think, oh, that's not a variable name, that's a constant. You can tell them apart. Some people in Python do the same thing. And, the rules are simply, the rules are the rules. Don't use a built-in function. Start it with a letter or an underscore. But these are conventions. These are just, hey, if you're doing it right, this is the way generally people do it. And you want to do it this way because eventually you're going to go into some company and you're going to be faced with reading thousands of lines of code. And you want to be able to read it and understand, oh, they're doing it the same way I was taught. So I understand what they're doing here. It'll make sense. Okay. So this dynamic typing stuff is basically just talking about the fact that I think I already mentioned this topic. We have statically typed languages like C++, C#, where you have to declare your variables at the top. That's statically typed, and Python is a dynamically typed language. So that's what we're talking about here with dynamic. So if somebody asks you on the test or quiz or something, whether Python does statically or dynamically typing, we do dynamic in Python. Okay, and the type inference thing we already talked about, where it's going to see something and infer what type it is. So if I have, let's see if I can do this. Pencil. Okay, so let's say I have type and I put double quotes ABC in here. So what is that going to tell me that this is? String. Right. Easy cheesy. Another example, type (17.4). What float, right? Okay, let's get fancy. Type of X, what's that going to tell me? We don't know, right? We don't know. It depends on what X is, right? What came before this? Did I say X equals 4? If so, it's going to be an int. Okay, what if I say type of x times what do you think about that one? So I've got a decimal here in this constant, or it's literal. I've got this variable. Can I infer deterministically what the type of this is? I can rule some things out. I mean, assuming that this compiles, right? I can rule out this x being a string or y being a string, but this is a float. So I don't know. Try it out. Run your command prompt and see what the rule is. Does it create an int or does it create a float? Okay, there's another thing while you're doing that. There's another concept in Python where something can be of no type. So it has no value and is of no type. So if I say z equals none, then that has a special meaning in Python. And other languages have a similar syntax. They might say null. Sometimes it's a lowercase null. Sometimes it's a capitalized null. But you know, most languages have something like this where you can say z contains no value. And you can use that for your logic. You can do things like if z has no value, if z is equal to none, or if the type of z is nothing or none, then you can use that to your advantage in certain circumstances if you need to. Anybody come up with the answer to this yet?
Yeah, define the variable. It's like I said, variable not defined, so it's like even like one name error.
In Python?
Yeah, it just says that X hasn't been defined yet, so it can't process anything.
Okay, fine. That was not fun. Well, if you before you do this, if you say x equals 4, now we know it's an integer, right? Yeah.
Instead of doing X, Y, I put in integers with the float and it just came as float.
Okay. So in C++, I think it goes left to right. Apparently in Python, the float supersedes the integer and it makes the whole expression a float then. But like in C++, if x was an integer and I multiplied it against a float, it would just truncate it and it would do integer arithmetic. It would multiply x times 17, not 17 times 4. And if you didn't know that, I've spent many minutes of my life trying to figure out what was wrong with my program, and that's what it ended up being, because my variable was an integer, and I was trying to do floating point math with it, and it was getting truncated. So it is a thing. Just realize that.
And gaming X is not defined, yeah.
Okay, I'm going to open up my command prompt here too. I think I can make this big. Big, big, big. There. That's a satisfying size. Okay, and so I just type Python. And now I'm in the Python environment. Yep, it's working. Okay, so our example before, I can say x equals 4. Print the type of x times 17.4. And it's a float. Type of 17.4 times x. Type of x is int. So you can see that's what's working. The floating point being part of the expression is superseding the integer, and it's upcasting it to a float, the whole expression. All right, what else do we want? Oh, if I say x equals none, I say type of x, then none type. So then I can say if type of x equals none type. Is that how I do it?
2 equals n.
Huh?
2 equals n. 1 equals n as n.
Maybe it's just none.
So type of x is not equal to none. Maybe it's single quote none type.
So that is none.
Okay, we'll try that. So eventually we'll get to it, right? No, that's not it either. Well, anyway, it's possible. So just Google, how do I test an if statement whether the type of my variable is none or not? What else can we do here? All right, here's something else I wanted to point out. So if I say x equals 17, type of x, it's an int. If I say x equals mark, it changed, right?
Oh, I see now. So type just explains what type of function it is.
Well, what type of data it is.
Okay.
Yeah, what the data type of that variable is. would be
Right.
different.
I was paying attention.
Yes.
Now I see. I'm like, oh.
And so that's just pointing out that for a variable, you can change the value and you can also change the type. In a statically typed language, you can change the value, but you couldn't change the type because you have to declare ahead of time what type it is, right?
Oh, good question. So what would you use type for in like big programs or like your experience? Like what have you used type for?
Usually it's when you get an error that says, hey, I can't do that plus operation. Like right now, if I said x plus 5, it says I can only concatenate a string with a string. And I might be thinking at 3 in the morning, what?
And then you forgot to add the int.
Yeah, or maybe I meant to say x plus 5. And that worked, right? But those kind of errors that you see in your program, you're trying to debug those, and then you're just stymied, and it's like, well, what the heck type is x? Oh, it's a string. That's the root of my problem. And I start tracing back to see where I assigned x last, and I overwrote the value of it.
So why did the second time it gave you a mark 5,
Because it concatenated
the x and the 5?
the string mark with the string 5. Remember, like if I type 1, 2 plus 3, 4, because those are both strings, I get 1, 2, 3, 4.
Oh, I see. Yeah, 'cause of the
It's concatenation, not addition.
if you were to do it without the brackets, it wouldn't do anything.
Right. If I said 1, 2, plus 3, 4, I get 46,
Oh,
because it's doing math. It's not doing concatenation.
If you like define X and like define Y and then say like Z equals X plus Y, can you do like type Z or is it just not gonna like that?
Yeah. And so in Python, is it def x int? No. I mean, there's a way to define things in Python. If you want to, I don't remember what it is though. But yeah, like in C++, you'd say int x, you'd say x equals 5. And if you said x equals mark, it would say, sorry, I can't assign a string to an int. But in Python, it says, yeah, sure, I'll overwrite your perfectly good integer with a string. Because it's dynamically typed. It's meant to do that. It does it on purpose. It thinks it's a feature, not a bug. Yeah.
Could you give an example of a complex div?
A complex data type. If I said x equals dictionary, what is it? New dictionary? I don't know. I don't know the syntax, but if I'm creating a list of stuff in a dictionary, then this is a complex data type called dictionary, and it's meant to create a list of things. But it's not like this. You'll have to just Google dictionary in Python. But the difference is a list of things. I could probably do the list one, because I think the list is just this.
Yeah.
So now I have a list. So if I say type X, it's a list. I just don't remember the syntax for declaring and initializing a dictionary. If I did, that would work too.
You have to put variable name and then colon, then the mark in a quotation.
Like that?
No, okay, so you have to put name, then colon, mark.
the name.
Oh, like that. Yeah, so that's a dictionary, right? Okay, so the difference, like I was saying, between a dictionary and a list is just a list of things, like Mark, Bob, Joe. A dictionary is a lookup list where everything has a key and a value, a key and a value, a key and a value. So what I did with the Y example there is I created right, so now I have a dictionary with 2 elements. Element number 1 is Mark, element number 2 is Bob, right? It's a key and a value, a key and a value. But those are complex because they're objects in formal sense of the word. In Python, those are considered objects, not intrinsic built-in basic data types. So it's an object of type list and an object of type dictionary. I wanted to do a little bit on prompts with that thing that I mentioned earlier, because this might help you with your assignments, to help you code them. So we all know the print hello, that syntax, and I get hello on the screen. But if I say, like the example that was in the slide, see how it splits them onto the next line? When it hits that \n, it goes to the next line. I guess technically that would be a line feed, so I'd have to say return, ooh. Yeah, it actually did that in Python. I'm surprised. So a \r is literally a carriage return. All it does is goes back to the beginning of the line and continues printing from the beginning of the line. Whereas the carriage or the \n actually split it up to a new line. See?
Oh, okay.
Yeah, so it printed the word carriage, and then it hit the \r, which popped it back to the beginning, and then it typed return over the word carriage. Is that cool? I don't know. If you have a reason to do that in your program, that's probably cool. If you accidentally do \r instead of \n and it messes up your output, you're probably thinking it's not so cool.
Is there like a center function, or is it just /t/t/t to get it to
Yeah.
the center?
Yeah.
So the /r is, you start from the beginning of the line and then you finish it.
Yeah, so it printed CARRIGE \r, brought the
Oh.
cursor back here, and typed RETURN.
So if you do the N, it would just do the 2 lines.
Yes.
So if I do like more stuff after, like, let's say like you added more words to it.
Yes. So if you said, like a lot of people in their programs, they'll do things like my cool program v1.0, and then on the next line, they'll say input, or x equals input, enter a number. Right? But now you know, you can just type input, if I could type, \n, enter a number. And voila, it prints both lines. So I don't know. So some people like one way because, you know, the first way I did it, you have 2 short lines, and the third way is 1 long line. Some people prefer fewer lines of code. Some people prefer narrower lines of code so you can see everything on one screen. Your choice, you know, that's why they do it that way. Same when you're formatting your output down below, you know, if you're entering a bunch of numbers and you're going to print them out later, you can say, let's do the tab one this time. Print x \t y \t z. Right, so there's my thing spaced out.
Wait, the T spaces out.
Yeah, it's a tab, so it inserts, I think, 8 characters. So then I can say \n, 1 \t, 2 \t, 3.
So I can do like,
Yeah, so now I get columns, they're all lined up.
so you can like make a table for that. Okay.
Yeah.
I see.
So if you wanted to like do like tic-tac-toe, you would do it kind of like that then?
Maybe,
Yeah, you could do that. I mean, it's a little more complicated.
yeah, but that's,
That's a
okay,
good idea.
so that's great, I like where you guys are going with that, you're thinking of, that's an interesting feature, but how could I actually use that in a program? And that's all programming is. You learn more and more of these features, and then it becomes more of like a puzzle, right? How do I solve this puzzle using the tools that they gave me? And then you learn more tools, and it's like, wow, that new tool is going to make this thing I had to do the hard way a lot easier. And that's what this is. Just using the \t's and the \n's in there, there are easier ways of doing this that we're going to see next chapter.
So, if, yeah, it's like the gentleman said, if we can do it next year. So now, would you use infinite, like, you know, so I'm trying to think about it right now. And would you use like the T and then, you know,
Yeah.
use it there? So make like 3 columns and then.
Yeah.
Just use like it.
Yeah. Knock yourself out. Be as creative as you like.
I'm gonna try to do it honestly.
That's awesome. Okay, yes, it's basically your preference on how you want to do some of this stuff to satisfy what you have in your head. This is where I talk about how programming is a lot like painting. You know, if you're Rembrandt, you know, Rembrandt has a picture, he's sitting there with a blank canvas and he has this picture in his head, what he wants to paint. And he keeps adding paint until it looks like what's in his head. That's the same thing with programming. It's a very creative endeavor where you have this problem. Hey, I want to implement a game called tic-tac-toe. How do I make what's on the screen become my tic-tac-toe game? Has anybody ever done turtle graphics before?
What's that?
Ooh, so I would challenge you to Google Python turtle, because you can do graphics on the screen with turtle graphics. It's basically just this interesting idea that somebody came up back in the 80s when the Apple I computer, or Apple II computer was coming along, where you basically have a starting point and you can either move to or draw to another point. So you move forward, you turn, you move, you turn, you draw, you move, you draw, you move, and you can create pictures with turtle graphics.
Is it like HTML, for example?
No,
No, it's still just using regular Python code. It's just a little weird. You have to like import turtle.
yeah,
Yeah.
Import what?
import turtle. Yeah, we haven't gotten to libraries yet, but yeah, you'll see it on the example. if You Google it.
Too big. I mean, I'm getting it, so. It's like, yeah, put my mind where I guess.
Yeah, I was playing around with that earlier, actually.
Yeah,
So you can draw stuff like this.
Yeah.
So this is examples of the syntax. You either go forward, go left, you go up, down, you know, you move, draw. So you can just create some of these things.
So would it be like an extension for Python?
See? So I just copied and pasted that code and it's drawn. I mean, I don't know what it's drawing, but it's drawing a bunch of stuff. Hopefully it doesn't draw a naked picture of somebody and get me in trouble. But anyway, yeah, have fun with it. But you know, you could literally be Rembrandt and literally think of a picture in your head and write the code to produce that picture. If you wanted to.
Okay, random.